Did you ever want to prepare cold drink for your friends and you had it to make very quickly? Well, what to do? You take as cold water as possible from the tap, put it in the fridge and wait until it cools down, right? Well, maybe not. Maybe if you use warm water, it will get colder soon. Strange? In 1950, a boy called Mpemba tried to make ice cream as soon as possible. He made some ice cream mess with cold water from the tap and some ice cream for hot water in the tap. He put them both in the refrigerator and, surprisingly, the mess that he made with hot water started to freeze earlier than one with cold water. Quite strange. He reported it, he told about it to some scientists, and they also didn't expect it. So they tried to experiment it on it. So we'll try to do this experiment ourselves. We'll prepare water of different temperatures, put it in caps, put it in fridge, and see which one starts to turn into ice first. So we have now prepared some water at 0 degrees Celsius by melting snow. We have prepared boiling water, which has 100 degrees Celsius, of course. And now we'll prepare water of different temperatures and put it in these cups. We'll prepare water by mixing different amounts of freezing and boiling water. We'll prepare water of 0, 25, 50, 75 and 100 degrees. Now, 10 minutes after putting the cups in the fridge, we are checking if the crust of ice has started to form on any of the cups. No, nothing yet. Checking again for ice after 1 hour. This time we have first spotted ice forming on the cup of water at 25 degrees. But no ice on other cups. After approximately 1 hour and 10 minutes, we are checking again. We still have ice in the water of 25 degrees. You see it? And what about the others? No ice in the water of 0 degrees? In the water of 50 degrees? Oh, there is ice. Evaporation. The evaporation of the warmer water reduces the mass of the water to be frozen. Evaporation is undetermined, meaning that the water mass is cooled by vapor carrying away the heat, but this alone probably does not account for the entirety of the effect. Convection. Accelerating heat transfers. Reduction of water density below 4 degrees Celsius tends to suppress the convection currents that cool the lower part of the liquid mass. The lower density of hot water would reduce this effect, perhaps sustaining the more rapid initial cooling. Higher convection in the warmer water may also spread ice crystals around faster. Frost. Frost has insulating effects. The lower temperature water will tend to freeze from the top, reducing further heat loss by radiation and air convection, while the warmer water will tend to freeze from the bottom and sides because of water convection. Solutes. The effects of calcium carbonate, magnesium carbonate, among others. Thermal conductivity. The container of hotter liquid may melt through a layer of frost that is acting as an insulator under the container, allowing the container to come into direct contact with a much colder lower layer that the frost formed on, ice, refrigeration coils, etc. The container now rests on a much colder surface, or one better at removing heat, such as refrigerator coils, than the originally colder water, and so cools far faster from this point on.